Hello friends, today we are going to start with the new chapter, that is enumerations, autoboxing and annotations, that is metadata. This chapter examines three recent additions: enumerations, autoboxing and annotations, which is also called as metadata, that is data about data, and it is offering a streamlined approach to handling common programming tasks. And this chapter will also tell you about Java's type wrappers, that is type converters, and introduces reflection. Now we will start with enumeration. What is enumeration? Versions prior to JDK 5, that is Java 5, lacked one feature that many programmer was needed, that is called as enumeration. Before Java 5, there was one feature missing. That feature was enumeration. Enumeration is a list of name constants. So whatever constants like we were creating in C and C++, like in using defined constants, same way enumeration can create a constant or list of named constants for us. Java offered other features that provide somewhat similar functionality, such as final variable that will create a constant. Many programmers still miss the conceptual purity of enumeration. Okay, we were having final to create a final variables that is constant, that will not be modified throughout the program, but still there was need for something better, something pure, the pure constant, like in C and C++ defined constants, especially because enumerations are supported by most other commonly used languages. Okay, enums are supported by other languages, and there was missing in Java. So prior to Java 5, after Java 5, it was added to programming language. Beginning with Java 5, enumerations were added to the Java language, and they are now available to the Java programmer as a pure constant. In their simplest form, Java enumerations appear similar to enumerations in other languages. So our enumeration, like Java enumerations, are same as the enumerations in other programming languages. Okay, but it is only skin deep similarity. Such as C++, enumerations are simply list of name integer constant. Okay, like in C++, we were having enumerations, but it was only the list of name integer constant. And in Java, enumeration defines a class type. So we can have a class constants also, like integer constants and other type of constants. We can also have class type constants. By making enumerations into classes, the concept of the enumeration is greatly expanded. Okay, only the basic data type constants creation is different thing, and group of variables and constant, that is class, and creating its constant, that is creating class constant, is a different thing. Since Java is introducing class type constants, it is widening the variety of way that we can handle those, create and handle those constants. For example, in Java, enumeration can have constructors, methods, and instance variables. Although enumerations were several years in the making, Java's rich implementation made them well worth the wait. Okay, since Java introduction to Java, then Java 1.0, 2.0, 3.0, up to whatever versions were there up to Java 5, we were waiting for the pure constants to be created. After so much waiting, Java made it worth wait. Fundamentals of enumeration. An enumeration is created using the enum keyword, like in C++. For example, here is a simple enumeration that lists various apple varieties: enum apple, Jonathan, Goldendale, Reddale, Winesap, and Cortland. It identifies Jonathan, Golden, and so on are called enumeration constants. So whatever constants, whatever we are writing inside this, in opening and closing curly braces after enum and enum name, those are all called as constants. Each is implicitly declared as public static final member of apple. Okay, so each constant is declared implicitly. You don't have to write it explicitly, but it is implicitly declared as public static and final variable of enumeration apple. The type is the type of enumeration in which they are declared, which is apple in this case. Okay, the type is the type of enumeration. Like whatever name you are giving to enumeration, all constants of will be of that type only. Okay, so in this case, Jonathan, Golden, Reddell, Winesap, Cortland are the type of constant apple. Thus, in the language of Java, these constants are called self-type, in which self refers to the enclosing enumeration. Okay, whatever name you are giving to the enumeration and whatever you are writing inside that enumeration, all those constants will be declared as constants of that particular type. Once you have defined enumeration, you can create a variable of that type. Okay, so like you are grouping some constant into enumeration and you can create a variable of that particular enumeration. Like you are creating object of class, like a variable of class and variable of int. Likewise, you can create a variable of that particular type. However, even though enumeration define a class type, you do not instantiate or enum using new. Okay, so only you declare the name of variable. You do not instantiate it using new keyword. You only declare and use an enumeration variable in much the same way as you do one of the primitive type, like integer, float, character, or whatever, or class variable. For that, you are for class objects, you create it like class name, object name is equal to new class name. But in enumeration case, you do not use new keyword. For example, this example will declare AP as the variable of enumeration type apple. Apple AP and semicolon. There is no new keyword present. AP is of type apple. The only values that it can be assigned or can contain are those defined by enumeration. Okay. So AP is type of apple. The only values it will be holding, or it can or whatever values we can insert into that AP are those defined by the enumeration. This assigns AP the value Reddell. Okay, so AP is equal to apple dot Reddell. So we can assign the values in that such a way. AP, that is variable of enumerator is equal to enumeration name apple dot value Reddell. Symbol Reddell is preceded by apple dot. Two enumeration constants can be compared for equality by using the equality is equal to, that is equality relational operator. For example, this statement compares the value in AP with the Golden Dale constant. If AP is equal to apple dot Golden Dale. So you can define, or you can compare in such a way that AP is equal to apple dot Golden Dale. An enumeration value can also be used to control a switch statement. Okay, you can use those constants in switch, and all of the case statements must use constant from the same enum or group you are creating, as that used by the switch expression. For example, in your apple, you are having constants like Smith, Jonathan, Golden Dale. These are the constants. Or whatever, if you are passing the AP variable, for example, enumeration variable AP, in all the cases, you can only have the values that you are passed to initialize the enumeration apple, which is perfectly valid. Here, whatever I have explained now, this is given over here. In our case, apple enum was having Jonathan, Golden Dale, and so on, all the constants. Those constants can be used over here to compare the value of this AP. In the case statements, the names of the enumeration constants are used without being qualified their enumeration type name. So you can directly give it as a constant. Winsap not apple dot winsap is used because it is already knowing that you are checking for the enumeration constant equality. Instead of using the equality, if you are using equality, what you will use? The statement that we have already seen, this statement. if AP is equal to apple dot golden del. In this case, you have to use the enumeration apple and dot. But in switch case, you are passing the AP. So before starting with AP, before starting with the switch case statement, it will already check that this AP refers to what? It is the type of enumeration. So whatever constants will be there inside of the switch case, which will be automatically of type apple. So no need to write over here apple.jonathan, apple.winesap, and so on. So only you have to pass the AP. So in this case, for equality checking, switch is greater than if. This is because the type of enumeration in the switch expression has already implicitly specified the enum type of the case constant. There is no need to qualify the constants in the case statements with their enumeration type name. Okay, so you no need to write it like apple dot enumeration constant name. Attempting to do so will cause an compilation error because Java compiler already know that AP is type of apple. When an enumeration constant is displayed such as println, the name is output. Okay, so whenever you will try to display the constant, enumeration constant, it will display you the name of its output. Apple.winsap is displayed. The following program puts together all of the pieces and demonstrates the apple enumeration. So now we are declaring the apple like we have already declared. So whatever statements we are understood in this way, we will group them all and create one program. Jonathan, Goldendale, Reddale, Winsap, and Coatland. Class enum demo. Here apple variable AP is created. AP is equal to apple.reddale. Value of AP is reddale will be displayed. Here AP is assigned apple.goldendale. So goldendale will be assigned here. If AP is equal to apple.goldendale. AP contains goldendale, true or false will be displayed. Okay. Now AP is already initialized to apple.goldendale. So AP and goldendale, these values are already same. So AP contains with display. If AP is equal to apple.goldendale, yes, so it will display this line AP contains goldendale. Next we are using switch case Jonathan, case Goldendale, Reddale, and so on. Jonathan is red, Golden Delicious is yellow, Red Delicious is red. Wine sap is red, Portland is red. The output from the program is value of AP is reddale. AP contains Goldendale. It was true, so it displayed this line. Then Golden Delicious is yellow. Why it displayed this line? Because we have already initialized AP to apple.goldendale. So this will be passed with Goldendale. AP is equal to apple.goldendale, and this will match with this statement. After that, it will display Golden Delicious is yellow. It will break out of it, and then it will display this line. Okay. And what is the answer of this? Reddale value of AP. Value of AP. First of all, it was apple.reddale. So it was displayed apple.reddale. After that, it initialized it to Goldendale. Then it checked for the equality of apple.goldendale and AP, and it was true. It displayed this line, and since it was initialized with Goldendale, it will display you switch apple.goldendale here, and it will display this line. Now, so you can write go through the output. Now, values and value of methods. Enumeration automatically contains two predefined methods, value and value of. So in Java class, that is enumeration, it has already given two methods by default methods. Those are value and value of. Values and value of. Okay. Public static enum type values. So it will display, it will give you the enum type array, which is of type public and static. And second method will return you value of that particular string that you will be passing, and it will return its enum type. Values method returns an array that contains a list of enumeration constant. Okay, so whatever constant, like in the previous example in apple, There are Winesdale, Goldendale, Reddale, and so on. All the constants will be written if you are passing this, you are calling this function values, and if you are passing value of, it will return the enumeration constant whose value corresponds to the string passed in the string. Okay. Enum, apple, same example we are taking. Jonathan, Goldendale, Reddale, Winesap, and Portland. Now, apple is created, apple AP. Here are all apple constants. Apple, all apples is equal to apple dot value. So it will return you the array, and that array will be stored in the all apples array. And type of that all apples array is apple because it is returning the enum type. For apple A colon all apples. Okay. So for all apples array, I will take each and every apple constant in a variable like we used in for loop, like for integer I is equal to 0, I less than 10, and I plus plus. That I will be used to iterate through the for loop. Here I am using this A to iterate through the for loop. Here I will print out this A. If I am printing it out like A, it will give me the name of its name as its output, name of the enumeration constant. Then new line. Then use value of method, apple dot value of Winesap. So Winesap value will be stored in the AP, and AP contains AP will be displayed. So output, here are all apple constant: Jonathan, Goldendale, Reddale, Winesap, and Cortland. And AP contains Winesap. Then AP contains which value? Winesap, because we have already passed it using a string Winesap. Okay. This program uses for each style for loop to cycle through array of constant obtained by calling values. For the sake of illustration, the variable all apples was created and assigned a reference to the enumeration array. So all apples will be the array through which your for loop will iterate. However, this step is not necessary because for could have been written as shown here, eliminating the need of the all apples variable. Like for apple A, apple dot values. Okay. So apple dot values we have already stored in apple all apple array. Instead of using that line, you can directly give it like this: apple dot values. It will automatically return you the array of all apples, and for each A, it will display you the value of apples. Notice how the value corresponding to the name Winesap as obtained by calling apple dot value of Winesap. Okay. Here Winesap, we are providing it as a string, and it will be saved into this AP. Value of returns the enumeration value associated with the name of the constant represented as a string. C++ programmers will notice that Java makes it much easier to translate between human readable form of enumeration constant and its binary value than do other languages. In short, Java's enumeration type is much more easier than C++ enumeration type or C enumeration type. Okay, in C also we were having C enumeration, which were having all the constants created, but only primitive types: integer, float, character, boolean, and so on. There was no class type included, and also some extra methods that was added by Java to make it as simple as possible. This is a significant advantage to Java's approach to enumeration. Now, Java enumerations are class types. This is the basic advantage. Java enumeration is a class type. You don't instantiate an enum using new. It otherwise has much as the same capabilities as other classes. So Java enumeration is a class type. Why? Because enum has created as a class by default in Java, so that using that particular class, you can use that enumeration much the same way as we operate on the classes. The enum defines a class, gives powers to the Java enumeration that enumerations in other languages simply do not have. Okay. The fact that enum defines a class, enum is a class, gives power to the Java enumeration It will empower the Java enum class that enumerations in other languages simply do not have. So in other languages like C and C++, enum is not a class type, and for that purpose Java is advantageable in this case. You can give them constructors, add instance variables and methods, and even implement interfaces. Okay, so in classes we can have constructor, variables, methods, and interfaces. As the same way, in enum of Java can have constructor, instance variable, that is member functions and member variables, and even it can implement interfaces. It is important to understand that each enumeration constant is an object of its enumeration type, which is declared as a class of a Java language. When you define constructor for enum, the constructor is called each enumeration constant is created. Okay. When you are creating the constructor for enum, like a class in Java, the constructor is called each enumeration constant is created using enumeration name, enumeration variable, and semicolon. Much the same way that we are creating class object, like class name, class object is equal to new class name, opening and closing parenthesis, and then semicolon. When you are writing this line, before even you are creating writing new keyword, the object of this constructor of this class will be called automatically. That is, default constructor will be called. In the same way, since enum in the Java is a class type, when you write this line enumeration and enumeration object and then semicolon, its default constructor will be called automatically. Whatever constructor you are creating, if you are creating default one, it will call that, and if you are creating a parameterized constructor, it will call that. Also, each enumeration constant has its own copy of any instance variables defined by the enumeration. Like each enumeration constant has its own copy of instance variable defined by the enumeration. Enumeration constants you are declaring inside the enum type. Like in Apple, we were having Jonathan, Golden Dale, Red Dale, Winesap, and so on. Those constant will have its own copy of any instance variable. So every constant in that will have its own copy of the defined by the enumeration object. Okay. So Jonathan will have, if you are creating suppose two objects, Apple AP semicolon, Apple AP1 semicolon. So Jonathan will have own copy of AP also and AP1 also. Then Reddell will have its own copy of AP and AP1. Then Reddell will have its own copy of AP and AP1. Okay. Now we will see one example. Jonathan 10, Goldendale 9, Reddell 12, Winesap 15, Portland 8. Private integer price. Okay. So this is enumeration enum Apple with a constructor. Here we are creating a constructor. Here we are also having one variable, private integer variable, which is price of each apple. Then Apple will be initialized, Apple constructor is having the price as a parameter. Price will be initialized to P. Okay. Same way we are creating constructor in classes. Then integer get price, return price. So we can also have methods in enumeration. Then in public static void main, what we are doing is Apple object we are creating, enum object Apple APs we are creating. Now Winesap cost. Okay, so Winesap cost will be Apple dot Winesap dot get price cents. Okay, so I will display the Winesap price for that particular enum Winesap, all apples and all prices. So how I will do it? I will display all apple prices, like for apple A colon apple values, it will return me array A cost A dot get price cents. Okay, so this price I am already setting using this Jonathan 10, Goldendale 9, Reddell 12, Winesap 15, and Cortland 8. So these are the prices of this particular constants. So how I will display them? For each and every enum constant, I am iterating this for loop, and how I am displaying this for system.out.println a cost a dot get price, that will be giving me the price of that particular constant and cents. So this will display me like this: wine sap cost 15 cents, all apple prices, Jonathan 10 cents, golden cost 9 cents, 12, 15 and 8 cents. Okay, so this way we have understood constructors of enum. Now, this version of Apple adds three things. First is the instance variable price that we have already seen, which is used to hold the price of each variety of apple. Second is apple constructor, which is passed the price of an apple. Then third is the method get price, which will return to the value of the particular apple constant. When the variable AP is declared in main, the constructor for apple is called one for each constant that it is specified. Okay, when you are writing this apple AP semicolon, automatically this constructor will be called one for each constant that is specified. Okay, so every constant will have its own copy of the instance variable. Now, constructor example, same example we are using. Here also we are declaring the apple constructor, overloaded constructor apple. Here is a parameterized constructor. Here we are overloading it for the default constructor. Then price will be initialized to -1. Then rate price, return price. Notice that in this version, rateDel is not given an argument. It means that the default constructor is called and rateDel price variable is given the value -1. Okay. So all are initialized. Jonathan price is 10, golden Dale is 9, red Dale is no value, wine sap is 15, Cortland is 8. All will be initialized to this, okay, and this price will be initialized to this particular price. But since red Dale is having no value, this constructor will be called for it and price will be initialized to -1. Two restrictions that apply to enumeration. Enumeration can't inherit another class. Enum cannot be a superclass. Okay, it cannot be a subclass. That is, it cannot inherit another class, base class, and it cannot be a superclass. This means that enum cannot be extended. Otherwise, enum acts much like any other class type. Okay, only two restrictions are there. It cannot be a subclass of any other class, and it cannot be superclass of any other class. Okay. The key is to remember that each of the enumeration constants is an object of the class in which it is defined. Okay. The key, what you have to remember, that each of the enumeration constant is an object of the class in which it is defined. Now, enumeration inherit enum. Although you are not inheriting any class, it's by default inheriting one basic class, that is by default Java lang enum class, and which is automatically inherited, so you don't have to do anything for that. This class defines several methods that are available for use by all enumerations. Enum class is described in detail in next sessions, but three of its methods warrant a discussion at this time. Okay, there are many more methods, but three methods we are discussing over here. You can obtain a value that indicates the enumeration constant's position in the list of constants. This is called its ordinal value. Okay, so you can obtain a value that indicates enumeration constant's position, at which position it is stored in an enumeration in the list of constants. Its ordinal value, and it is retrieved by the calling ordinal method shown here, final int ordinal. It returns the ordinal value of the invoking constant. Ordinal values begin at 0. So, like an index in an array, we are starting with 0, 1, 2, that is 0 position array value, first position array value, like this. We can find out the ordinal value, that is the position of the particular constant in a particular enum, will be retrieved by using final int ordinal, and it will the final value. You cannot modify this value. ordinal value begin at 0. Thus in apple enumeration, Jonathan is an ordinal value 0. Then golden Dale has ordinal value 1. And red Dale has an ordinal value 2, and so on. That is the position of the particular constant. You can compare the ordinal value of two constants of the same enumeration by using the compare to method. Okay. So how you can compare? Final int compare to. You can compare the ordinal value of two constants of the enumeration by using compare to method. Enum type is the name of the enumeration and is the constant being compared to the invoking constant. Okay. For example, there are two enumerations and you want to check, you want to compare the ordinal value, that is position of one constant with the position of another constant of another enum. So you can do it using final int compare to method. Both the invoking constant and e must be of the same enumeration. Okay, sorry, I did the mistake. So both the invoking and passing parameter will be of same enum. There will not be the different enumeration. You have to pass it as a same. They both refer to the same constant with the same enumeration. Simply having ordinal values in common will not cause equals to return true if the two constants are from different enumeration. You can compare two enumeration differences by using equal to. Okay. Simply if you are having ordinal values in common will not cause equals to return true if the two constants are from different enumeration. The following program demonstrates the ordinal compare to and equals methods. Now, there are 5 constants in enum apple. Apple, we are creating 3 variables of apple, AP, AP2, AP3. Ordinal values. Here are all apple constants. A dot ordinal. For all apple values, I am iterating using A. AP is equal to apple dot red tail, AP2 apple dot golden tail, AP3 is equal to apple dot red tail. Demonstrate compare to and equals. AP dot compare to AP2 is less than 0. Okay. So we are checking with the ordinal values like AP. AP is red tail. Okay. So what is the position of red tail? 0, 1, 2. Then golden tail. Golden tail's value is 1 and red tail's value is again AP3. Value is again red tail, so it will be again 2. Okay. So AP dot compared to AP2 is less than 0. So AP will comes before golden tail will comes before red tail. And if AP compared to AP2 is greater than 0, then AP2 comes before AP. So this way we are comparing the position of the constants in the enumeration. If AP dot compared to AP3 is equal to 0, we are displaying AP equals AP3. That is red tail is equal to red tail in our case. And AP equals AP2, error. If AP equals AP3, AP equals AP3. Now, first of all, it will give you the all ordinal values. Golden tail comes before red tail. Red tail equals red tail. Red tail equals red tail. Red tail is equal to red tail. Okay. So in all the things, all the ways we are displaying red tail is equal to red tail. Okay. So these things you have to remember. Simply having ordinal values in common will not cause equals to return true if the two constants are from different enumeration. And you can compare two enumeration differences for equality by using equal to. So all of the ways we are giving us the equal values, like this way. First of all, if AP is compared to AP3, that is red tail is equal to 0, it will give me this answer. Then AP dot equals AP3 is equal to Compare to will give me position, that is 0. Then AP equals AP3 will also give me the equality of AP and AP3, that is red tail and red tail. And this will also give me AP is equal to AP3 will also give me equality of the two variables of two objects of apple enumeration. Now we will see another enumeration example. We will look at the different example that uses enum in chapter 8. It is previous chapter. An automated decision maker we created that was having no, yes, maybe, later, soon, and never. And that were declared within an interface, and those were treated as a constant. Okay, those values were like 0, 1, 2, 3, and so on, and used to represent the possible answer. While there is nothing wrong, there was nothing technically wrong with that approach. Enumeration is a better choice. Okay, so same example we will use as an improved version. Here we will improve its version of that program that uses enum called answers to define the answers. You should compare this version to the original version that we had already declared. Sorry, it was chapter 8. Improve version of decision maker. No, yes, maybe, later, soon, never. So what will be the ordinal values or positions for these all constants? 0, 1, 2, 3, 4, 5. No will be 0, yes will be 1, maybe will be 2, later will be 3, soon will be 4, never will be 5. So there are 6 constants over here. Now, we are taking random number as in the previous example. Answers asked integer probability is equal to integer 100 into random of next double. So next double will give us 0 and 1 as two values, and this will be multiplied by 100, converted to integer and saved into probability. If probability, not problem is less than 15, return answers dot maybe, problem less than 30, if problem less than 30, return answers dot maybe. Else if problem is less than 30, return answers dot no. Else if problem is less than 60, return answers dot yes. Else if problem is less than 75, return answers dot later. Else if problem dot less than 98, return answer dot soon. Okay. Else it's the default answer, return answers dot never. Now in a class, ask me static void answers result. Switch result. No will be printing no, then yes, maybe, later, soon, and never. Okay. Same we are calling the values as the same way. Question Q is equal to new question, creating object of class question, and then passing that particular call to the answer method, and we are displaying the output. Okay, so the output will be same, means output will be random as in the previous example. Okay, so this way we have completed the part 1 of enumeration. In the upcoming session we will try to cover the remaining topics of enumerations, part 2, theory part. Okay, so meet you in the next session. Thank you so much.